our readers and visitors of the show are very interested in technical stuff about your level 3 system. So what can you tell us about it?
Well, I mean, the most interesting, if you sort of want to look at technologically, the most interesting are probably the DA converter and the speakers. The DA converter uses no oversampling, i.e. no digital filtering. It uses no analog filtering. And it has basically, it takes the raw data, we take the raw data from the disk and process it into the analog domain with as little interference as possible. And then we send it to the amplifier. Now this runs completely counter again to what the rest of the industry is doing, which is using lots and lots of processing and lots of what should we say, signal manipulation, all of which leaves a footprint on the sound. There is nothing you can do to the sound that does not leave a footprint. It is a total myth that you can get away with. It all takes away, or you add something that wasn't there in the first place. So that technology, in our opinion, is the only way to get the information off the CD and convert it into the analog domain in a way that does the minimal damage. What should we say? The second most, and I know they look very common or sort of fairly garden variety, are the speakers. The technology there is again runs very counter to a lot of what the industry believes and is correct. We tend to, we've designed them to be close to the room boundaries. We've designed them so that the port is designed in terms of its dimensions and its behavior to pressurize the corner or the wall behind the speaker. It works better in the corner, I have to say, because you've got two surfaces to work with instead of, or three surfaces, the floor and the two corners. And what this does is it allows the speaker to be more efficient in the rendering of the bass that you get out of it. But it also makes the job of the amplifier much easier, because the amplifier doesn't have to work so hard. Which is why with a 9-watt amplifier we can make an awful lot of noise, to the point where the room next door who've got a 100-watt amplifier complain when we play things that are a little bit too enthusiastic, shall we say. Mm-hmm. It's, to go into more detail about the design is not so easy, because a lot of what we do is done empirically. That we learn, we listen to certain solutions, and then we learn from listening to them. And this is why I mentioned the comparison by contrast method first, because it really is absolutely central to how we end up with the solutions that we choose. Because from a technical perspective, I really don't care. I'm not married to the idea that it has to be a single-ended amplifier. If I came across a solution that was better, I would drop the single-ended amplifier like that. The problem is, I haven't come across a solution that does a better job. In fact, all the solutions we've tried do a much worse job. And the same goes for the oversampling in the digital converters and lots of other things. It goes all the way down to component level, where we prefer certain types of parts that have certain properties. We believe, for example, that surface area is very important. You need a large surface area to be able to conduct a musical signal. Because a musical waveform is not just a voltage. A musical waveform is a voltage with an associated amount of current. And we don't know how to measure how much current is supposed to be there. There is no way of doing this that we know, that I certainly know of, and I don't think anybody else does either. And that's the secret ingredient, if you will, that you can measure the voltage all day long, And this is what people did when they designed the CD system. This is what they've done with all kinds of other things. And when they look at distortion, for example, you look at distortion in an amplifier, they look at high power. Music doesn't start at high power. Music starts with nothing. Which means if you look, unless you look at what happens when music comes in, you don't know what the amplifier is doing with it. It's very interesting to look at 75% power, and the reason people do this is that you can get things to measure quite nice there. But if you look at making an amplifier with feedback, for example, that has very low power, and you only look at 0.1 watts, it looks terrible, because the feedback loop hasn't started working yet. You need a certain amount of level to get the feedback loop to work. And of course, when the signal comes from nothing and it starts, that's where you get all the distortion. Once you've got that distortion, you can't get rid of it. The feedback loop doesn't do that, because the feedback loop comes after the signal. The feedback loop is reactive. It is not proactive. It's not ahead of the signal. It always reacts to signal and signal level, which means that the distortion you get in the very, very start of the signal, you then amplify all the way through the amplifier, no matter how low the distortion is when you look at the scope. It's completely irrelevant. You know, it's like testing a car on a pair of rollers and then try to describe how it handles in the corner at 100 miles an hour. It's complete nonsense. Mm-hmm. And you know, we prefer realistic tests for these things. Or if there isn't a realistic test, the only test can come from here. There is no other test. You know, and they can write all the papers in the AES journal, and they can do all this, but all of it is based on a static set of measurements which do not describe music. And that's the biggest problem that I think we have as an industry, is that we're using a set of parameters that simply don't describe the reality of what it is we're trying to do. And until we decide, or until, I mean, I don't do this, we do what we do, but until the rest of the industry realizes that the methodology they use is wrong, they will never be able to improve their product. It will be, you know, a dance around the same problem. You know, you look at speaker design, for example. While I've been doing this, it started out with flat impedance. Then it became flat phase. Then it became flat frequency response. Then it became something else. Then it came back to flat impedance. Then it came to flat frequency. And it just goes around. And they don't look, they look at one parameter, and then they try to build their theory around that. It's a three-dimensional problem. How can you use one parameter? It's crazy. I mean, you know, it's like trying to, the comparison I always use is that you put an elephant in the room, you turn off all the light, and then you turn on one light, but you're not allowed to look at the elephant. You're only allowed to look at the shadow of the elephant, and from that you have to describe what's going on. That's music relative to measurement.